So the topic of today's video is area of regular polygons. Our objectives: I can state and use the formula to find the area of regular polygons. I can find the area of regular polygons, and I can find the measure of central angles in regular polygons. So, just a quick recap about regular polygons. We're introducing some new things. If we were to look at this regular polygon right here, we have a hexagon inscribed inside a circle. And if a polygon is inscribed in a circle, it just means that all of its vertices hit that circle. So that's what that is. If we look at this, P is called the center of our polygon, and the radius of our polygon is the length from the center to our vertice where it hits that circle, so it would be the radius of the circle as well. And if we look at our diagram, PM and PN are radii of this polygon. It's the plural form of radius. The apothem of a polygon is the distance from the center to any side of the polygon, and it is perpendicular to side, so it comes to a right angle. And PQ is the apothem of this polygon. A central angle of a regular polygon is an angle formed by two radii drawn to consecutive vertices of the polygon. So angle MPN is a central angle of this polygon. And to find the measure of a central angle, you divide 360 degrees by the number of sides. And a quick note about the apothem is the apothem bisects this central angle. So, if we want to find the area of an n-gon, the area of a regular n-gon can be found by dividing it into congruent triangles. So if we were to create 3 more triangles, all of these triangles would make up the polygon, would be congruent. So we're just going to derive the formula for area of a regular polygon, or n-gon, with n being the number of sides. And so you start out area of one triangle times the number of total triangles we have equals the area of the polygon. So then A equals 1/2 S, our side length, times A, that's our height of this triangle, times N, our number of sides. And like it says here, just base of a triangle is S, height is A, number of triangles is N. Move on, A equals 1/2 times A times N times S, and we got that just by using commutative property and associative property, moving things around. Okay, and lastly, A equals 1/2 A times P, with P being the perimeter of this polygon. And we can get that because there are n congruent sides of length S, so their number of sides n times S is what is actually going to give us the perimeter of this polygon. As we see, perimeter is n times S, so our formula is 1/2 A times P. And if you are missing needed information, we can use information we've learned in past units. If you have 2 side lengths of a right triangle, you can use Pythagorean theorem to find the third. If you have a right triangle with 30-degree, 60-degree angles, or a right triangle with a 45-degree angle, you can use your special right triangle ratios. And if you have a right triangle with a side length and an angle measurement, you can always use your trig ratios. So, we want to find the area of a regular octagon with side lengths of 15 inches and a radius of 19.6 inches. So if we were to kind of fill out this diagram, we draw another radii here. That's a straight line. And then we draw our apothem here. Let's try that again. We'll actually build it up, make it a little cleaner. So we have our apothem there, another radii here, and we can mark that this here is a right angle. So if our apothem bisects this angle and also bisects this segment of 15, we know our radius is 19.6 inches. We want to know what A is, and we know that half of this half of this side length is, or this little segment right here is half of 15 is 7.5 inches. So to find A, we could use Pythagorean theorem. So A squared equals 19.6 squared minus 7.5 squared. So that comes to be 384.16 minus 56.25. So A squared equals 327.91. Take square root of both sides. Find that A is going to be 18.11 if we round to the nearest hundredth inches. Now to find our area of our octagon, we set A equal to 1/2 of our A, 18.11, and then multiply that by our perimeter, 15 times 8, 15 inch side lengths times 8 sides. It's just 1/2 of 18.11 times 120. Multiply that through, we get 1086.6 square inches. That is our area of this octagon, our regular octagon. Remember, this area is only for regular polygons, so they are both equiangular and equilateral. Okay, another example. ABCDE is a regular pentagon inscribed in a circle with a center at F. We want to find the measure of angles AFB, AFG, and GAF. So to find the measure of angle AFB, that is a central angle. So to find that, we simply take 360 divided by number of sides. So angle AFB equals 360 divided by 5, and the measure of angle AFB equals 72 degrees. So we know that one. Now to find the measure of angle AFG, we know that this apothem bisects the angle, so we simply just need to take 72 and divide it by 2. So measure of angle AFG equals 72 divided by 2. Measure of angle AFG equals 36 degrees. So we know this is 36 degrees. This whole angle as a whole is 72. So to find the measure of angle GAF, we simply need to add up these two angles and subtract from 180. So 36 plus 90 gives us 126. So 180 minus 126 equals 54 degrees. So the measure of angle GAF equals 54 degrees. Okay. Review. Area of a regular polygon, again, regular polygon, equilateral, equiangular. A equals 1/2 of your times your apothem times your perimeter, and also 1/2 your apothem times the number of sides times your side length. Okay, make sure, go online, do that reflection, get your bonus points, ask any questions you might have, and we'll see you tomorrow.